Assalamualaikum dan selamat sejahtera. Nama saya adalah Anista binti Saleh. Hari ini kumpulan saya iaitu kumpulan 12 akan membentangkan tajuk Chinese Mathematics. Baiklah, saya akan menerangkan tentang tajuk Chinese Mathematics di bawah subtopik kemunculan zaman purba Cina. So, China is documented civilization in China from 3000 before Common Era until 2200 Common Era. So, China refers to roughly on the area shown. So, this area shown is China, north of the Yangtze and around the Yellow Rivers. So, it is known method of enumeration dates from the Shang dynasty commensurate with the earliest known oracle-born script for Chinese characters. So, this is the most information on the Shang dynasty lah. Many original oracle bones have been excavated from Anyang, its capital. So, we know that China capital is Anyang. So, ini during the Zhou dynasty, especially toward the end in the Warring States period, a number of mathematical texts were written. So, the Warring States period is an excellent example of the idea that wars lead to progress. Rapid change created pressure for new system of thought and technology. So, in China, the use of iron expanded, so leading to major changes in warfare and commerce. So, indeed, we know that China meliputi tentang ilmu astronomi dan juga kalender kan. So, itu pasal China lah. Seterusnya, kita tengok kepada important mathematical texts. Sebagai contoh, saya ambil the oldest suspected mathematical text is the Zhou Bi Xuanqing. So, maafkan saya. The mathematical classic of the Zhou, Gnomon and the square parts of heaven. So, ni adalah mathematical text. So, teks ni dia mengandungi earliest statement of Pythagoras theorem as well as simple rules for computing fraction and conducting arithmetic. So, kita nampak kat sini dia punya proof lah. Claim C iaitu C square equal to 4 times 1 over 2 AB plus bracket B minus A bracket square. Inilah. So, of course, the Chinese do not attribute this result to Pythagoras. Instead, it is known as the Kaogu, where these words refer first to the shorter and then the longer of the two non-hypotenuse sides of the triangle. So, ni tak boleh nampak. Okay, salah satu tokohnya iaitu Liu. Liu made other contribution to mathematics, including accurate estimates of pi, made similarly to Archimedes. He made also particular use of the art in principle. Describes how to compare areas and volumes. The first one is areas and volumes are invariant under translation, and the second one is a figure is subdivided, the sum of the areas or volumes of the parts equals that of the whole. So, ni lah Liu gave the argument about the required squares. Ni alternative proof of the Kaogu. Tadi itulah. Okay, seterusnya. Liu juga extended the ordering principle to analyze solids, comparing the volumes of four basic solid: cube, bifang, right triangular prism, rectangular pyramid, tetrahedron. Inilah. Okay, this could be assembled to calculate the volume of say a triangular pyramid. Contohnya ni. So, dia memerlukan satu cube, empat right triangular prism dan juga empat right rectangular pyramid. Ni, rectangular pyramid. Okay, seterusnya adalah the bamboo problem. Saya ambil ni sebagai contoh. This problem is taken from the 9 chapters on the mathematical art. Ni lah. The question is about a 10 feet long stem of bamboo is broken ni in such a way that its tip touches the ground 3 feet from the base of the stem. So, ni adalah 3. Maafkan saya. So, ni adalah 3. What is the height of the break? So, saya ada bagi penyelesaian tapi saya ingin terangkan sikit. So, ni saya tunjukkan sini adalah ni. Oh, sorry. The rest all in. So, saya buat yang baru. Ni. So ni yang bambu, ni adalah 3. Ni 10 tadi, sepatutnya ni 10. Yang 10 tu kan. Tapi dia nak height, berapa height yang tu. So ni height. So di sini ni kan. So ni kita letak dia 10 tolak H lah. 10 tolak H. Okay, 10 tolak H. Ni, okay. So kita guna teorem Pythagoras. So bila kita guna teorem Pythagoras, kita dapat macam ni. Okay, so kita kembangkan, kita dapat macam ni. So H square ni kita potongkan. So kita dapatlah macam ni hasilnya. So kita dapat nilai H. So H adalah 91/20 ataupun 4.55 feet. So ini adalah jawapannya. Okay, itu saja dari saya. Seterusnya saya serahkan kepada rakan saya.
Hi, I'm Onur Awatif. Next is Chinese enumeration. Chinese had two parallel systems of enumeration where both are essentially decimal. The first one is Oracle bone script and modern numerals. This is the earliest Chinese writing, dates from around 1600 BCE. The numbers 1 to 10 were recorded with distinct symbols with extra symbols for 20, 100, 1000 and 10,000. This is the symbols. The second one is word numerals. This is the second dominant form of enumeration, dates from around 300 BCE and was in very wide use by 300 CE. Numbers were denoted by patterns known as zongs and hengs. Zongs denoted units 100s, 1000s, 10,000s, while hengs were for tens, thousands and 100,000s. There was no need for a zero in this system. They were often used. Road numerals is very practical at that time, where they could easily be scratched in the dirt. They were often used in conjunction with a counting board. Counting board is a grid of squares which sticks could be placed for easy calculation. This is the symbols for zongs and hengs. There are two famous problems in Chinese mathematics. The first one is 100-fold problem. Dates from 5th century CE. It was copied later in India and then by Fibonacci in Europe. This is the example. If cockerels cost 5 chiens, hens 3 chiens and 3 chickens cost 1 chien, and if 100 folds are bought for 100 chiens, how many cockerels, hens and chickens are there? Okay, so we got 5x plus 3y and plus 1/3z equals to 100. And then x plus y plus z equals to 100. The answers are simply stated as 4, 18, 78, 8, 11, 81, 12, 4, 84, while the possible solution 0, 25 and 75 was not stated. The second problem is Chinese remainder theorem. It is used for solving simultaneous congruence equations. It traveled to India where it was described by Brahmagupta and then to Europe. This is the example of the problem. 3 thieves entered a rice shop and stole 3 identical vessels filled to the brim with rice, to whose exact capacity was not known. The thief got their vessel and examined. All that was left in vessel X, Y, Z were 1, 14 and 1 respectively. The thief did not know the exact quantities that had stolen. A used a horse ladle with capacity 19 to take rice from vessel X. B used a wooden shoe capacity 17 to take rice from vessel Y. And C used a bowl with capacity of 12 to take rice from vessel Z. What was the total amount of rice stolen? Alright, the solution is like this. N, 1, 14 and 1. The answer is that N 3,193. This is the smallest possible solution. All such are congruent modulo. 19 times 17 times 12 equals to 3878.
Yes, Assalamualaikum. My name is Huida. I would like to numeration and computation. Two tortoiseshell and bone parts of religious ceremony. One side for question, the other side was hidden. The correct which appear were interpreted. Numerical information about number of animals is number days and months, men's lost in battle, etc. Numerical information was based on the decimal system and was both additive and multiplicative in nature. The selection of symbols that were used by having multiplicative properties, 200 is represented by the symbol 2 and the symbol 100. 4,000 is represented by the symbol 4 and the symbol 1000. The symbol 1000 is look like scorpion form but not included in the illustration. The largest number found on the shark's bone and the tortoise shell were 30,000. For additive nature of the system, the symbols were paired to indicate addition. Here is the way the number will appear. 5,050 represented by the symbol, and the system is not a positional system, so it had no need for zero. And the other example for the 4,359 given by the symbol, and the other example is 8,873. Two main theories involved. The symbol are phonetic. Symbol 9 look like fish hook, as in Chinese call fish hook, with a word that close to the sound of 9. The number symbols are of religious significance, used by the soothsayer who were the priests of the time in religious ceremony. Some people say that perhaps 100 represented a tooth. People at the time counted up to 10 on their fingers, then 100 for each tooth, then 1,000 for the man having counted all parts of the body.
Assalamualaikum and good morning. My name is Nur Hananusna binti Bakri, and I will continue with road number system. Road number system were used from the 4th century when counting boards came into use. Numbers were represented by little rods made from bamboo or ivory. A number was formed in a row with the units placed in the rightmost column, the tens in the next column to the left, the hundreds in the next column to the left, etc. The most significant property of representing numbers this way on the counting board was that it was a natural place value system. 1 in the rightmost column represented 1, while 1 in the adjacent column to the left represented 10, etc. Road number follows a natural place value system. For example, number 21 is symbolized by 3 rods. However, the road number system can be upside down, so there are two possible representations. You can see the illustration given. However, the problem is the symbol 3 root might be number 111 or 12 or number 21. They found a clever way to solve this problem. they use the form in the lower row, while in the tens column they use the form in the upper row, continuing alternately. For example, the number 1, 2, 3, 4, they use the symbol upside down alternatively. And for the number 90390, there was still no need for a zero on counting board. For a square, simply left blank. The alternating form of the numbers again helped to show that there was indeed a space. Next is Suzu numbers. Suzu numbers developed from the root number system and it cooperated with number 0. Suzu numbers also known as Huama. The last one is modern numbers. The illustration given is about the number Chinese use until right now. These numbers are used for everything except check, banknotes, and coins. During 14th century after dynasty abacus came to be used in China. Abacus is just like invention of counting board. It almost same with counting board, but the difference is abacus use beads sliding on the wire to represent numbers, while counting board use rod to represent numbers. During that time, abacus mostly used by machines that use addition and subtraction in their calculation. The illustration here is about abacus showing the number 46,802. So I will show to all of you how to use abacus. Firstly, each one of the bits below will represent 1, while each bit in above will represent 5. So to form the number, the bit would be slided to the middle bar. So to form number 4, 4 bits from below slided to the middle bar. And the next one is 1 bit from below was slided to the middle bar and 1 bit from above will slided to the middle bar. 5 plus 1 equals to 6. So the next one is 3 bits from below is slided to the middle bar and 1 bit from above will slided to the middle bar. So 5 plus 3 equals to 8. So for the number 0, the wire is left blank. And lastly, 2 bits from below will slided to the middle bar to become 2. So now we have the number 46,802.
Assalamualaikum and hi, saya Sarwani. So kita akan teruskan dengan Mathematics in China. Pelajar di China ni dia akan mula belajar math pada usia yang sangat awal. Dan mereka juga ada buku math, dan buku math mereka ni akan mula dengan topik multiplication pada first semester of second grade bila mereka ni berumur 7 tahun. Macam mana mereka nak ingat multiplication tu, mereka akan guna multiplication rhyme. Maksudnya macam kita kalau kita nak hafal sifir, kita akan 2 kali 5, 10, 3 kali 5, 15 and so on. Dan bila mereka belajar math ni, mereka akan bersungguh-sungguh sesuai dengan cultural tradition of Chinese maths mereka. Routine practice is the most efficient way to learn. Ataupun kalau kita nak lebih faham, practice make perfect. Mathematics in China ni diajar 15 jam a week. Cikgu dan parents di China ni dah ada high expectation lah untuk student dan anak-anak mereka, sebab apa-apa pun ibu bapa ni nak akan terlibat dan sangat prioritaskan anak mereka ni kalau melibatkan pelajaran, especially in math, sebab math ni subjek teras. Dianggarkan tempoh ajar math ni 40 minit untuk primary school student dan akan extend kepada 45 minit in secondary school student. Then cikgu juga dia akan set at least half an hour untuk bagi homework untuk primary school student and more homework untuk secondary school student. And then matematik in China ni is made to understand. Maknanya goal untuk pendidikan mat di China ialah untuk develop conceptual and procedural knowledge through rigid practice. China ni dia akan use whole class instruction, engaging all students in the material and prompting feedback. Maknanya mereka akan wujudkan interaksi, interaksi antara guru dan pelajar ataupun student ke student. Then Chinese students are taught to understand numerical relationship and to develop and prove their solution to problems in front of the whole class. Maybe akan ada satu student yang akan pergi ke depan dan selesaikan masalah mat kat papan putih. Okay, when a Chinese teacher introduces a new topic, they tend to use different kinds of examples that vary in difficulty. Maknanya mereka tak gunakan contoh yang biasa-biasa, mereka akan gunakan contoh yang berbagai lah. Jadi pelajar ni maybe dia akan lagi berfikir. So itu cikgu-cikgu ni dia akan guna juga yang further beyond H, macam why, how, what if, macam tu lah. And then dia akan emphasize the use of precise and elegant mathematical language. Maknanya tak boleh sebut saja-saja. Dia macam bio juga, ada satu benda tu dia kena sebut in term of bio, tak boleh sebut macam tu. Next, teacher's time. Nearly all Chinese teachers teach a single subject rather than multiple subjects, and most of them teach only 2 classes per day in primary and secondary school. And Chinese math teachers ni usually spend a considerable amount of time each day writing out detailed lesson plan (RPH), ataupun mereka akan betulkan homework ataupun tanda kertas exam. And Chinese math teachers are not very good at integrating concepts across the curriculum. Yang ni maksudnya walaupun mereka ada 15 jam per week untuk belajar matematik, tapi cikgu-cikgu ni dia akan komplain juga yang mereka tak ada masa yang cukup untuk ajar, sebab mereka ni ada banyak lagi benda nak buat, macam buat test, buat exam, macam tu lah. And some good math teachers, particularly those who come from quality schools, encourage people to learn about the interrelationship mathematics has with daily life. Yang ni macam cikgu kita mungkin pada set induksi mereka akan tanya student untuk try to relate apa yang mereka akan belajar dengan topik yang mereka nak belajar masa tu, ataupun pada akhir sesi PDP. So rasanya dekat sini mereka try untuk aplikasikan konsep Kebat supaya mereka berfikir. And most people in rural areas have few chances to access to this high quality teaching. Sebabnya cikgu dekat China ni dirasa tertekan sebab mereka macam tak ada benda nak tunjuk dekat student ni konsep math ni in real life. So sebab tu mereka rasa lagi senang untuk mengajar je dengan informasi yang ada. Thank you.